This review for quiz 1, video 2. So once again, most of the time when you're doing these problems, you want to simplify everything in terms of sine and cosine. So this first one, tangent is sine over cosine. So I'll make a parentheses here. So sine x over cosine x. And then times cosine x. And then cosecant is 1 over sine. So here, the cosines are going to cancel and the sine's going to cancel, so this all equals 1. So if I illustrate that by crossing these off here, the cosines cancel with each other and the sines cancel with each other. So we're just left with 1. Second one, so I leave sine x alone, and secant is 1 over cosine. And then sine x over cosine x is tangent x. And then number 3, so tangent is sine over cosine. And secant is 1 over cosine. And then you're going to multiply by the reciprocal here. So the numerator leave alone. Sine x over cosine x. And then the denominator is 1 over, or cosine x over 1 when you multiply by the reciprocal. Multiply those two together, the cosines are going to cancel, left with sine x. So number 4 is to multiply this all together using the distributor property. So you have 1 minus cosine x plus cosine x minus cosine squared x then you have 1 minus cosine squared x. And that's a Pythagorean identity. The 1 minus cosine squared is equal to sine squared. And then 1 plus cotangent squared. That's a Pythagorean identity. Also 1 plus cotangent squared right here is cosecant squared. So, and this is secant squared. So now I have cosecant squared over secant squared x. And then cosecant squared is 1 over sine squared. And secant squared is 1 over cosine squared. And then you want to take this fraction, complex fraction, leave the denominator alone, and multiply by the reciprocal. So cosine squared over sine squared is just going to be cotangent squared. All right, and then this one here, you need to get a common denominator of sine x. And then in the numerator, have cosine squared x. And then if I multiply this by sine x, then I have sine squared x. And then the next step would be that the numerator is a Pythagorean identity. Cosine squared plus sine squared is equal to 1. So I replace cosine squared plus sine squared with a 1. The denominator stays as sine x. And 1 over sine x is cosecant x. All right, so that's the first 6 there. Number 7, I want to convert cosecant squared into 1 over sine squared. So I'm going to leave sine squared alone. And then I'm multiplying that by 1 over sine squared x. And then minus sine squared x. So you have 1 minus sine squared x and that equals cosine squared x. So secant squared minus tangent squared is equal to 1. So I don't know if I have that one written back here, but let's go down here. Yeah, I have that one written here. Secant squared minus tangent squared is equal to 1. So this right here is equal to 1. 1 minus, and then cosine squared. And 1 minus cosine squared is sine squared. And then the last two down here, you want to start with a more complicated side, work on that and see if it equals secant squared. And then the same thing over here, work with a more complicated side, see if it's equal to cotangent squared. So 1 plus cotangent squared is equal to cosecant squared. So back here at the identities, the Pythagorean identities, 1 plus cotangent squared is cosecant squared. And cosecant squared minus 1, back on the identity page here, is equal to cotangent squared. So you have cosecant squared over cotangent squared. So cosecant squared is 1 over sine squared. Cotangent squared is cosine squared over sine squared. And then you want to take this complex fraction and turn it into a multiplication problem. And so you multiply by the reciprocal of this fraction here, or ratio. So the numerator becomes sine squared x. And the denominator cosine squared x. So 1 over cosine squared is equal to secant squared. These are going to cancel here. Sine squares are going to cancel. And then this last one here, I'm going to work on this side and see if it equals cotangent x. So sine x and cosecant becomes 1 over sine. And tangent becomes sine over cosine. does that equal tangent x? Let me fix this one over here because you should all be questioning whether this is equal to secant squared x. So does this equal secant squared x? Right over here. So you carry the secant squared x all the way down here. And the final step, yes, the left side equals the right. All right, back to the last problem. So I'm going to carry this cotangent x all the way down in this problem. So when I multiply these two together, I get a 1. So the next step would be 1. And then sine x over cosine x is tangent. And cotangent x, cotangent x. All right, so that's the second review of the first quiz. Let's stop the video here and then post it to the classroom.